Every house starts with a foundation. Now, what goes into before a foundation and during a foundation? That's what this video is about. We hope you enjoy. Step number one, preparing for your foundation. What's underneath the actual foundation system? Now, I'm sitting here on a slab, but whether this was a full basement foundation or a slab, the principles are the same for preparing for that foundation. So we talked about during the excavation in our previous video, having 75 kPa bearing capacity. It's very important that the ground has that capacity, or if the ground is irregular and needs to get built up with a compacted gravel pad, which essentially is what I'm standing on right here with this slab foundation system, is a compacted gravel pad. So this site here in particular, slab, was excavated. Approximately 2 to 3 feet of topsoil was removed. Geotechnical engineer came in, confirmed that there was 75 kPa bearing capacity, and then this compacted gravel pad was installed and compacted. Okay, so as long as a gravel base is compacted to 98%, it's going to maintain that 75 kPa bearing capacity. So just like a geotechnical engineer comes in before the gravel is installed, that geotech also has to return after the gravel has been installed to make sure through a compaction test that that strength is maintained throughout the base. Now, if this wasn't a slab system and if it was a basement, technically a gravel pad wouldn't have to be done. Sometimes footings that are placed directly on the excavation are thicker at one end of the building or other to allow for a unlevel excavated area, but sometimes a gravel pad will still be installed regardless. Your subgrade has to be 75 kPa and your compacted gravel compacted to 98% to maintain the strength. Once you have that strength built to the underside of your foundation system, that foundation now is in a position where it's guaranteed not to move. Okay, so step number 3, after the compacted gravel pad is installed, now comes a time where you have to install your site services. So actually picture this foundation system not there. You have a gravel pad. Now you got to bring the services in. Once a foundation is installed, there's no place for services to come after that. So number 1, your electrical service. You can see here this heavy duty black pipe was trenched in underneath the foundation system. So through the gravel pad, you have your communications conduits as well. So these systems can come up right inside the outside wall. Alternative to that, you can see behind me where the blue pipe is coming out of the concrete is the water service. So the water service is penetrating the building envelope a little bit deeper because it needs to come in at a minimum below frost depth underneath the slab system. So where we are today, Chelsea, Quebec, approximately 5 feet of frost depth. So that water pipe comes in at least 5 feet below grade. But the most complicated part of your site services is your plumbing. So the septic system or the sewer pipe running out to the road will come in underneath the slab as well. But all of the plumbing, you can see in the background, all of the black pipes coming out of the slab with all the blue caps. Each one of these pipes represents a plumbing fixture. So plumbing fixtures all will have a trap drainage system. Also, there's sloped plumbing pipes that need to happen for drainage. And how the whole plumbing system works together, there's actually almost sometimes 24 inches of space that's required. So the gravel pad underneath a slab foundation system needs to be approximately 2 feet thick to accommodate the plumbing system alone. So after the gravel pad is installed, it's ultimately busted open with a series of trenches for all these services. And after the services are installed, that slab, that gravel pad is re-leveled again. And then you have your foundation system ready to go. Step 3 to your foundation system. Now, step 3 to your foundation system is one item that's not talked about enough, is your radon protection and your vapor protection. You can see here, there's a plastic vapor barrier that's integrated into the slab. This is also the effective radon barrier. Radon, if we don't protect against radon and moisture, we instantly impact the health of the building. Everything starts with the foundation, so your vapor and your radon protection starts at the foundation as well. Now, sometimes this plastic or this radon barrier will be installed underneath the slab system. That depends on the contractor. It can be done both ways. What's most important is the vapor barrier is integrated with the vapor barrier for the wall assembly and then the vapor barrier for the roof assembly. So it's a continuous vapor protected system for the whole building. It's where it starts. Also a continuous protected radon membrane. Radon gas coming out of the ground should stay in the ground, should not come into our houses. Radon is becoming the second leading cause of lung cancer amongst non-smokers. It's a big deal. It instantly affects the health of the building. So protect against that and install the radon barrier in your foundation. As far as continuous radon protection, it's very simple because it's just segregated to the foundation. What's most important is that you have a radon barrier. Radon is going to protect the health of the building, the health as you living in the home. It's one thing that is missing from most building codes across North America. Make sure one is in your home and you will stay healthy. Last part to the foundation video, the foundation itself. So there's a lot going on here. There's a couple porches, there's a garage in the background, and there's the house. But starting with the house, look at this thick insulated. This is 100% insulation apart from this 2x4, which is just there for fastening the outside wall. But we have about 14 inches of EPS, expanded polystyrene. It's plastic, but it's plastic built from recycled plastic beads. So it follows a green building material, but it's mostly there for thermal bridge protection. Now the thickness of this styrofoam, this EPS, will depend on your climate zone. We're here in southern Canada. That's the equivalent of approximately an R56. This can range anywhere from an R24 right up to an R60, depending on your climate zone, how much thermal bridge protection is required in your area. But the beauty of this system is it's a tray system. This is a 2,000 square foot floor system, 500 square foot garage. There's a few hundred square feet with respect to porches. You know, this entire styrofoam tray system was installed in a single day by a foundation company. So it goes down really easy, and once it's installed, it's the actual form for the floor system. So insulation, lots of thermal bridge protection, and lots of saving of labor. There's some steel reinforcement in this slab as well. The slab gets poured. These are some J-bolts there for fastening the load-bearing wall to connecting that to the foundation. Porches, porches, you can see the outside of this porch isn't styrofoam like the house because there's no thermal bridge protection for a porch, of course, since it's outside. But these porch slabs are also sitting on top of styrofoam. Any area that experiences frost in the ground is also going to require a perimeter styrofoam skirt. In this case, the styrofoam comes out about 4 feet from the perimeter of the building. It will also extend 4 feet outside the slabs so that no frost can get underneath the foundation or the porches to cause any frost heat. So once that concrete is poured, it looks beautiful, of course, and it's going to look beautiful into the future. Frost protect your foundation, but most importantly, thermal bridge protection, insulation protection is going to protect your health so that you feel comfortable in the building year-round. We hope you learned lots from this foundation video. If anything's confusing, drop us a comment, ask us a question. Most importantly, don't forget to like and subscribe.